Mm. All right, so I need to prepare for a technical interview for an F sharp position. F sharp being the programming language. In the last video that I recorded maybe an hour ago, I did the business rules kata. This time I'm looking at this supermarket kata, supermarket pricing kata, should I say. The description is as follows. This kata arose from some discussions we've been having at the DFW practitioners meetings. The problem domain is something seemingly simple, pricing goods at supermarkets. Some things in supermarkets have simple prices. This can of beans costs 65 cents. Other things have more complex prices. For example, 3 for $1. So what's the price if I buy 4 or 5? $1.99 per pound. So what does 4 ounces cost? I honestly forgot how many ounces are in a pound. It's 16, right? I don't even know anymore. Buy two, get one free. So does the third item have a price? This kata involves no coding. The exercise is to experiment with various models for representing money and prices that are flexible enough to deal with fees and other pricing schemes, and at the same time are generally usable at the checkout for stock management, order entry, and so on. Spend time considering issues such as does fractional money exist? When, if ever, does rounding take place? How do you keep an audit trail of pricing decisions, and do you need to? Are costs and prices the same class of thing? If a shelf of 100 cans is priced using buy two, get one free, how do you value the stock? This is an ideal shower time kata, but be careful. Some of the problems are more subtle than they first appear. I suggest that it might take a couple of weeks worth of showers to exhaust the main alternatives. Goal. The goal of this kata is to practice a looser style of experimental modeling. Look for as many different ways of handling the issues as possible. Consider the various trade-offs of each. What techniques are best for exploring these models? For recording them, how can you validate a model is reasonable? Okay. So let's add on to this. All right, so how do I want to do this? Let's add a new library or a new project. And this is supermarket prices. Something tells me I shouldn't do it that way. We'll call this specification to be your operations. This would be language. Okay. Operations. language. Maybe we just make this language right here. And we make this operations over here. Okay. Now what? So for the supermarket, it said that basically you get deals when you buy more than one uh, type of product from the supermarket, like 2 for 1, $1.99 per pound, stuff like that. So the model should cover these 3 considerations right here for supermarket pricing. 3 for $1. So what's the price if I buy 4 or 5? Okay. Let's think about this. So we have a type declaration for a given operation. Where what do we want to call this operation? I don't know yet. Right now, what's the most general, maybe abstraction? Do I want something general or do I want something domain specific to describe an operation? Say get price. Okay, that's the name of our operation. And get price is going to take what? It is going to take, I could say, products because it's a supermarket, or I could say items. An item could be abstract because it could be a product or a service. Can you purchase a service at a supermarket? There's like Western Union and stuff, but maybe I'm overthinking it. We'll go with, yeah, I still want to say items. Because you put items in the shopping cart. You don't really put products in the shopping cart, right? Okay, so we can say items. Okay, and what do you get out? If you want to get price, you get a price, right? Okay. So get price of what? Items. We could just say price of, and then it takes items and returns a price. Maybe that's better. I don't know yet. So then over here, we can say type, and we can say an item. What is an item? An item has a name. Okay. Is that it? Would an item have a quantity? Within the scope of a supermarket, I'm thinking it does. But then how useful would that be? So, for example, you can have an item that's like Ben and Jerry's cookie dough ice cream, a pint, but you may have a sale where you can buy two Ben and Jerry. You could buy one Ben and Jerry pint of ice cream, regardless of it being cookie dough, and you get the second one half off, right? Meaning that you could buy a Ben and Jerry's pint of ice cream cookie dough, and then you could buy a Ben and Jerry's pint of vanilla ice cream, and it will still apply that buy one get the other half off. So, do we really need quantity in here? Ah, my my hunch is my hunch wants to say yes, but I'm not gonna do it. We're gonna keep it simple for right now. So, what else is the item? Mm, $1.99 per pound. Item has it has some it has a weight to it. If it has a weight to it, then it's something that's tangible or physical, right? So, does the item have a a a unit of measure? Does the item have a unit of measure? And if so, I would assume that that would probably be a float. Uh, okay. Is there a better name for unit of measure? It could be. It's still not quantity. I'll leave it like this. Or no, I won't. So this unit of measure may be a separate item. It may be a separate type. So, I mean, what I mean is we could say type. Oh, shoot. Hold up. Take two. What I mean is we could say type. One more time. What I mean is we could say type and we could say unit of measure. And then it's going to be. Oh, why is this so? And then it's going to be something like unit. That's going to be a string. And then what? It has to be a number, right? So a unit, for example, could be weight. Um, it could be ounces. Well, that's still a weight. It could be weight. It could be. How else would you measure a product outside of weight? Length, such as inches or feet or meters. Okay. So that would be the unit. And then what would be the property name to describe the measure? Mm, you just call it measure? Maybe that's a float. I'm not sure. So I wish I could find a better name for this. Uh, and you just call it measure? Unit you could say value, right? So you could do something like this right here. Okay. Still can't think of a better word than measure, but whatever. Um, what else? You have an item. The item has a name. It has a measure. Okay. So far, that's the language of our domain that we were able to come up with. But I have a feeling it's going to be iterated on. Now what? Oh, okay. I said items, so we could just say type item equal item sequence. Items equals item sequence, like that. Do we care if it's a sequence? I don't know. We're making a list for right now. Okay. We can import our language module. And then we have a price. What is a price? Is a price just a float? Is it a decimal? I don't know. I think it's a float for right now. Okay. So you have operation within our supermarket specification saying price of, and then we have items. Okay. And it gives you a price. Should that price have a description on it? It could, but I'm not going to go there because I could easily see how that gets complicated. But it should convey some type of description about why the price is what it is, right? I think that's valid. So you get a price of items, and that price of items probably would not be a float, but it would be a summary of why the items are priced the way that they're priced. Okay. So price isn't a number. Price is a domain type. Okay. It's a domain type of what? A price is a domain type of a list of items, whether it's empty, one, or many. Okay. Well, one thing we know is that there's probably going to be a summary. Oh, okay. So it's going to be prices. Okay. So you have type prices, and that's going to be a price list. Your price is going to have a summary. Well, first, your price is going to have a value first. How about that? We'll make it simple. We'll start off simple. A price is going to have a value. This is of type float. And that price is going to have items. The price is going to have items. Okay. And that price is going to have a description, maybe? Okay. That would be a string. Okay. So you get the price of items, and that's going to generate prices. That doesn't really seem like price, it seems like cost. This seems like this right here. Cost of items. And gives you prices. Maybe it doesn't matter. Price of items, and it's going to return prices. I don't like the name of this yet. Um, you say prices of items? That really sounds weird rolling off the tongue. You can say prices for items. I'm literally being petty now. We'll keep it like this. Should we really call it prices or price list? We'll call it prices. All right. Okay, so if we return back to this domain Kata description, 3 for $1.99 per pound, buy two, get one free. Okay. Let's cover the 3 for $1. If we go to our code Kata test, we can add a new test. We'll call this prices. Okay. And we could say code kata.prices.test. And then for the process payments, we say code kata.payments.test. And in theory, everything should be happy, right? And then we could just start modifying this stuff. So specifically what I mean, specifically what I mean is we can take this prices and we could say, what was the first consideration? It was 3 for $1. Okay. This right here, 3 for $1. 3 for $1, something like that. You have a setup, you have a test, you have a verify. Okay. Get price regarding 3 for $1 sale. Okay. So we still have an interpreter somewhere in here. It's payment processing interpreter. I guess we could say supermarket create a supermarket folder. Supermarket folder. We could dump you, my friend, in here. Okay. And so now we'll have a references specification in our test for supermarket. We can say open supermarket prices dot operations. And you probably say dot language as well. Something like that. Okay, now what? Um, we can define something. We could define an item. We could say let. What does the code Kata say? 3 for $1. Three for $1. Okay, fine. So what can we get for 3 for $1? You can maybe get, because I don't know. You can get a. I really don't know. Paperclip. Paperclip. All right. Equal. So this paperclip is going to be our item, and it's going to have a name and a measure. Name is paper clip, and the measure is going to be let's say unit maybe. The measure needs to be a float. I think that's what the type alias is. No, a measure is its own rich domain type. Oh, shoot. Okay. Which is a unit and then a value. Okay, I'm starting to see that this, my original domain model is probably not going to work for this. So you have a measure that is going to do something like this, where you have a value. Hold up. How do you define a measure again? It is a unit and a value. So you can say unit equals that value equals maybe something like that. So unit equals a unit could be gallons, it could be grams, it could be feet, inches, or it could be a paper clip doesn't have a unit. So what would you call something that? Do you call it a small paper clip? Do I just say NA? Let's just call it NA for right now. What about the value? The value we define as a float. So if we revisit this measure type that we define in an item, we said it has to have a measure. Well, does it? Or can a measure be maybe? If we make the measure like a maybe or an option in F sharp, then that's going to kind of add a little bit of complexity when processing. I don't think I want that. So if it's optional and I don't necessarily want to define it as optional within the type, that gives me opportunity to say an item that has a measure, like item with measure, and then item. But then that's no longer going to be abstract. That's not going to be abstract enough because then when I have an operation called price of, it only takes items. One can argue that you can make this like some type of like template abstraction. But even if you do that, like a template parameter, it still has to operate on a specific type. You can't mix types. And the only way that you can really mix types is if you use a discriminated union. That might be an option. So when I say a discriminated union, I don't think I'm going to go forward with this, but you can say type, and then you can say item type, and then you can say with measure, and then you can say no measure, something like that. And then with measure, you could probably say of measure. That's not what I wanted. You could say of, and why can I not do this? Of, and then you can say measure. And of course, measure isn't defined above it, it's defined below it. So I would have to add it like maybe right here. So in theory, I could do this. But that would be but I also have to define an item with measure, maybe. Like this stuff is getting complicated, and I'm not sure if I want to go down that path just to process it, right? I don't think I want to do that. Which leads me to this right here of an item that may or may not have a measure to it. And the measure takes a unit and then a value. And it's this value part that was kind of getting me in trouble because the value explicitly says it's float. Now, one can argue that, well, hell's bells, Scott, you can make a value whatever you want, right? You can make a value of you can say measure like you can say measure like that. Or is that not working? Hold up. Let's go right there. Could have sworn it goes right in the beginning. Oh, because I have to do something like that, maybe. Still not working. Why is that not working? Because that's the property name. Probably have to add it. That's that right there. But that doesn't really accomplish anything, I don't think. So go back, your measure, your item, measure. Okay, I think I'm just gonna leave it like this. And then your price. All right, so let's go back to our test. And for a paper clip, it doesn't have a measure, right? Your item measure none. It's been a while since I wrote out sharp. So can I just say none? Can I do that? Is that legal? Yeah. Okay. That looks kind of okay. So then what? We have a paperclip. Now what? Well, ultimately we want to be able to test an operation called price of. So we want to be able to say, why is this test for? We want to be able to say price of. So you could say let result equal. You could say let prices, or you could just say price. Let price equal, and then you could say. We didn't write an interpreter for this yet, did we? You'll have like a. Give me 1 second. You'll have like an interpreter. Yeah, interpret. Okay. So you say let price equals interpret, and then you'll have a price of, which I have to write this interpreter, and it would be a paperclip, something like that. In this case, if we say price of, put paperclip right here, and it probably reads better. Okay, so you got to add another project called interpreter. And we call it supermarket prices interpreter. Supermarket prices dot interpreter. So you have that. This module is going to be your interpreter. And then you say let interpret. This is going to take items, something like that, equal. And then it's going to return you a, well, first of all, this interpret is going to implement a, we got to add a reference to supermarket specification. Say open supermarket prices dot operations, and then you could also say language, right? And then you can say that this is going to implement your price of, like that, and then that's going to equal a function that will take a items, and it's going to return a price. But I thought it returned a list of prices. I thought that's what we decided. So if we go to our supermarket domain, it returns a list of prices. Okay. So we can say, well, if it's a list, then hell's bells, we can just have it empty for right now. Something like that. And we figure it out later. Did I use this construct of returning a function for the payment processor interpreter? I did not. No, I did. It's right here. Okay. So now what? Mm, there's this thing called items. And so your items, what about it? We probably need to say price of you probably say like list.map and then you pipe that into a price of in this case. So we could say like let prices equal that. Okay. And then it'll return prices down here once we figure this out. So, but first we need to define what price of is. So in theory, we could just say let private, and then we could say price of, and then we can say that this is going to take a item, and it is going to return a price. And so a price is a rich domain type that has a value, items, and description. So in theory, we could say the value equals, I don't know, I thought value was a float. And then the description equals something. And then what else does price have? Items. So it's going to look something like this, but we have to fill this in with details if this is the right domain type. Now what? This is complaining because we didn't. Oh yeah, we. Oh no, we're good. Items. This items. Oh yeah, this is supposed to take a. Oh, it's expecting this right here, I think. But we need to process. Yeah, we're not processing a single item. We're processing multiple items of the same type. Hmm. So should this really have name or should it have type? I'm thinking it should have type. And what we want to do is, I wish we could just automatically generate this as if we were doing C sharp, but it looks like we don't have that option. Type mismatch, expecting items. What's wrong with this? Is items is a list? Okay. No, no, no. Hold up. Give me a second. This price of yeah, it takes a list of items. This is a if I go to my language, this is a list of items. So what am I getting wrong here? It says that it's a type mismatch, expecting items as input that returns some generic value, but giving a function as input and then giving some other list type to return a completely different list type. Okay. We're supposed to return prices. And I thought prices was a list. And it is a list. If I were to comment this out right here, there would be no complaints. So let prices equal. Hold on, do I? How about that? Okay. Oh, I know what I did wrong. I gotta add actual. No. Items list dot map. Oh, that. And then this price is item has been so the item to price, but given items to price. It's saying that this should resolve it right here. Um, but this, even though this is compiled, this isn't right. It needs to take items. Um, okay. That's interesting. We get rid of the pipe to list on map. This is expecting this right here. That should work. Oh, that's price. That's why. Uh, that compiles. Okay. So what if this really just gives you a price for a list of items? If I did that, because your price has a your price is going to have a summary of items in it already. Hence this right here. Okay. So in theory, all you have to do is this right here. Which in theory could just be this right here. Which this would go right here. Now this description part could probably be renamed to sell, or you could say price description. Okay. We still got to determine the value. Still got to determine the price description. If we look at our test, it was get price regarding 3 for $1 sale. And we had a paper clip, one paper clip. And then we had a, get rid of this payment processing. That's not part of our Figmajig. Do I have a reference to interpreter for supermarket price? No. Add the reference to interpreter supermarket price. All right. And it should be, we need to open our interpreter for that. Interpret that. And this is expecting a list, I believe. That, okay. And then this is going to be our price. And then we can verify that our price should equal and the price it's going to be something like this, right? So the value, we can say, I mean, we can literally make up whatever we want to make up right now. Items is your paper clip. And then your price description is going to be substring. In this case, we could just say 1. Or we could just say 1. Put that in parentheses. 1. And then you could say paperclip. Use this string interpolation thing. Oh, God. Use this string interpolation thingamajig here. And you should be able to say paperclip.type. Okay. Something like that. So this test is going to fail. But when we hit interpret over here, we should be able to yeah. We should be able to say with items, we should be able to do a list dot map and then say function item, and then in theory we should be able to say get price, and then as for an individual item. I mean, that sounds wrong to me right now. And this get price thing needs to populate this right here. And we're just going to have, I'll show you what else. Let private, you could say item to price. That item to price is going to have a item, and it's going to return a price. And so what I want to say is you can do like a, oh crap, come here. You can say item, and then you could pipe that into a function. And then you can say, actually you want to say item.type, pipe that into a function. And then that's going to say like paper clip, something like that. And then you can return a 0.33 as in cents, and then anything else, you're just going to return, oh God. This price is going to be an option. You may get a price, you may not. But it would be some price value. And then when it hits wildcard, it just returns none. So then you have let prices equal something like that. But now we need to fit this in here. So you have some, and then how do we pack this in here? This would be 0.33. And then you could say, how do we have this? We had like one paper or one, and then over here we had item dot type. And then, yeah, so I'm butchering this right now. And it's an option list or price option list. So then, yeah, this is going to require more thought. I think the model that I have is okay. It just requires some deeper thought. Like something I know is likely going to be like a list dot choose, and that's going to say your fund V goes to, in this case your V is your price, right? And then it's like price pipes into a function. There should be an easier way to do this, but can I not just say price is sum? Yeah, it's right here. Is sum. That should be really all you really need to do. Nope. When you say choose, you pass in a function that takes the type that returns an option. I don't know. I gotta figure this out. If I were handed this question during an interview table, I would have failed the interview, which is the whole purpose of me doing this right now. I'm taking a break. Peace.